on the chart guide, what questions do you want to see, do, go over, have questions about? Seeing a lot of 1s and 4s, and then we'll do, yeah, 1s and 4s and then 5. One, really all of these can be done in Desmos. I'm going to, you could do one of two things, either just put the numbers in instead of the variables, or put each variable in and set each one equal to. So I'll show both. But you have to capitalize that x. And the line. So if I made x4, y10, and z2, my answer would be 3. Or you could have put this in as the square root of 4 over 2 squared plus 10. So either way, 3 or B was your answer there. And you can say you did that in Desmos. Or your line of best fit for number 4. I'm going to add in my table. And then type in my y1 tilde mx1 plus b. And let's round to 3 decimal places. So y equals 1.623 x plus 14.815. Questions on 1 or 4 before we do 5? And then for number 5, I'm just going to type in the inequality as is. And I see that this has a solid line because of it equal to. So that would be a closed circle at -5 shaded to the right. You would write x is greater than or equal to -5. Make a closed circle, draw an arrow to the right. And if you did it the way I did it, make sure you also say use Desmos, otherwise show your work. Just right there, this never opened. Questions on that? Look at your notes in front of you. Alright, so you are going to see a lot of rational exponents or fractions in your exponents. And we're going to be converting our rational exponents to radicals and vice versa and simplifying them. So with this, if you see something a to the 1 over n, that's going to be the same thing as the nth root of a. So a to the 1 over n is the same thing as the nth root of a, where the index and the number of the denominator are the same. You could also see it as a fraction where m, some m, is the numerator instead of 1, and that could be written one of two ways. The nth root of a to the m, or the nth root of a, all of that to the m. So we're going to practice some of this. So in number 1, I have x to the 1/4. That 4 would be my index, the n, so that would be the 4th root of x. And that can be simplified more. That would just be your final answer. Number 2, because everything is in parentheses being raised to the 1/2, that would, my index would be 2. You can put the 2 out here, but you don't need it. And everything underneath the radical would be 15n. If we could simplify 15, we would, but we can't because it would just be 3 and 5. It's not a pair, so it would say. How would I write number 3 in radical form? The number in your denominator is going to be your index, the number outside of the radical. How should we change that to radical form? So we will have to simplify this, but we can't do that if it's not in radical form. So we have to change it first. Look at number 1. That's a good example. Sophie, how could you write this in form? Based on how we wrote number 1. The cube root of 24. The cube root of 24. And then, because it is a number that we can simplify, we're going to do that. So now we have to think about the highest perfect cube that goes into 24. out your perfect cubes, 1 cube, 2 cube, 3 cube. Start dividing 24 by those numbers. Alright, did you have an answer? Charlotte, did you have an answer? 8 and 3. So the cube root of 8 we know is what? 2. So that would be 2 times the cube root of 30. You can put that in parentheses, but you don't need to. A lot of your rational exponents, I would definitely double check in your calculator, especially if you start to simplify or you have a lot of different numbers. So this one I'll show in the calculator. So put in the original 24 to the 1/3 and then 2 times the cube root in math of 3. And we get those same decimals. So in decimals and in the calculator, that's how you would check yourself. Do you have any questions so far before we continue? Let's look at number 5. Anytime you have an improper fraction, you could think about this one of two ways. One would be 2 goes into 7 how many times? 3. So that would be, I would multiply 2 and 3. I know that's 6. And then there'd be 1 left over. And I could simplify this 6 over 2 to be what? 3. So it'd be k to the 3rd, and then I would rewrite this in radical format. How would I write that? We'll get number 2 because it had the same fraction. That's going to be your same index, your same radical. What would this radical be? So based on this one, it would be the same. What was this one? So what type of root was it? Was it a cube root? Was this a fourth root? It was a square root. So then what would that be? Yes. So your final answer would be k to the 3rd times the square root of k. Do you have any questions, confusions, something's not making sense, you should probably ask instead of sitting in silence? Going on to let's do 7. We have to rewrite this. The fraction, the denominator is going to be your number root the numerator is going to be your exponent. How would I write that in radical form? Isaiah, how could we write this in radical form? Start with the number outside of the root. What would that be? Look at the denominator. That would tell you. What is the number in the denominator?
4.
4. So it would be a fourth root. And then how would I write the rest? All in parentheses. But we don't want to leave this like this because then we can apply our exponent rules. So you would multiply your exponents. So it would be the fourth root of a to the third, b to the third. But we can't simplify any further because 4 doesn't go into 3. Questions so far? How would we write number 9? Yes. 7 times the square root of 12w. And then we can simplify the square root of 12. The highest perfect square that goes into 12 is what? Say that again. 2. It's going to end up being 2, but what perfect square could we multiply to get 12? 3 and 4. And since there's not another w, that w is going to stay in, so I'm going to put that with 3. So we have 7 times 2 times the square root of 3w, which would give us 14 times the square root of 3w. Any questions on that one? The next section is switching. So we were in exponential form, writing it in radical form. Now we're going to start with radical form and write it in exponential form. Same rules apply. Whatever the number outside of the radical is going to be your denominator of your fraction. If you have exponents, that's going to be your numerator. How would I write number 10 in exponential form? So you can leave it like this, or you can put parentheses. You don't need the parentheses in this case, though. What about number 11? otherwise it just looks like y is being raised to the 1/2. What about number 13? Sorry, for 13. 11 to the power of 2/3. Good. 15. Ashley. Why did I write 15? Start with what's inside the parentheses. Focus on just this part first. The root's going to be similar to 11. And how we wrote 11, we're going to start off with that. It would be both 3 and m. To what power? It'd be the same power as 11. But in parentheses. But then we can't forget about the 7 out here. And you would use your exponent rules to multiply those two. So what would that new exponent become? Do one more of these and then any others you guys want to do from both sections. Do we have any questions on these ones we've done so far? Number 17. How would you write that? Don't focus on what's underneath the radical. Focus on the type of radical and the exponent that would go with it. See?
10 to the power of 5. A cubed.
If we were simplifying this, we would go further multiplying the exponents, but we're going to do that on the back. Are there any others on this page, either section that we want to see do go over before we go on to the back?
18.
8. Okay, so let's start off with how would we rewrite that in exponential form? index the number outside of the root. Brian, what's the number outside of this root?
9x.
The number outside.
Outside.
3. So how would I make that into a fraction? What would that fraction be? Yes. And again, if we were simplifying, we could move on and do something else with that, but we're going to keep that as this. Go on to the back. So, now, you're going to be given, a lot of these are going to be given in exponential form. You're going to use, if it's not an exponential form, you're going to change it to that, because we know the exponent rules, the product rule, quotient rule, power to a power, 0, and negative exponent rule. We'll be using those, and then simplifying to put it back in radical form to simplify it if we can. So in number 19, it's already in exponential form. We are multiplying like bases. What are we doing with the exponents? One of our exponent rules say when we multiply like bases, our product rule, we do what with the exponents? Sorry. Add that, yes. So these are they already have common denominators, so we can just add them. What would that new exponent be? X to the 5/3. And then, I mentioned this, but didn't actually do it. So you could break it down into, I know 3 goes into 5 once. So that would be 3 over 3 and however much that's left. 3 over 3 would just simplify to be 1. So that would be just 1x outside. And then how would I write this in radical form? Back at the previous page if you need to. See?
X times the cube of x.
Say the root first, so it would be the cube root of x squared. And 3 doesn't go into 2, so that would be your final answer. How you also could have done this is kind of the same thing. Write it in radical form. And then just simplify it from there. 3 goes into 5 once with 2 left. So either way. Okay, we're going to do 20 also because they don't have common denominators. So again, like bases, again we're going to add, but these don't have common denominators, so we have to change one of them. What would that new fraction become? E to the 7/4 And then using one of these methods, I'm just going to keep splitting it like this. But if you want to jump right into this, that's also fine. I know 4 goes into 7 once. So the first part was simplified to just be p. How would I write this in radical format? Okay.
Cubic of p to the power of 4.
Opposite. 4 is going to be your root, 3 is going to be your exponent. So it would be the 4th root of p to the 3rd. Yeah. Any questions, confusions there? In 21, we are dividing like basis. What are we doing with the exponents? Subtracting. We again don't have common denominators, so we have to change them, or at least one of them. So that would be m to the 10 fourths minus 7 fourths. What would that new exponent be? M to the 3 fourths. And then we can go ahead and write that in radical format. It would look very similar to the last one we just did. What would that be? Say the root first. So that's going to be your exponent. This is going to be your root. So you read that as the 4th root of m cubed. Questions or? (22), we are raising a power to another power. What are we doing with those exponents? Multiplying. So that new fraction would be what would that new fraction be? And then again, we write that in radical format. How could we write that in radical format? And now, how could we write that in radical format?
I don't know. So
let's look at this one. It'll be similar. Whatever the denominator is, you're going to put that outside the root. Whatever the exponent is, you're going to put that. Whatever the numerator is, you're going to put that as the exponent.
So again. It's like 5 over 5 to the root, and then they 5 and then the root and then
But that's going to be an exponent, a to the fifth.
and then 6.
So it would be the sixth root of a to the fifth, is how we would say that. Yeah, we're going to do one more of those, and then there's some negative exponents. It's kind of hard to see. They just look like longer fraction ones. There's a word for that. I don't know what that word is. But we're going to do 24. So with our exponent, we're going to do the same thing, multiply all of our exponents, but we have to remember about the exponent of 1. So that would be 8 to the 2/3 and x to the let's see what would that new fraction be. Use your calculator if you need to multiply 2 and 2/3. So because both of these have a denominator of 3, I'm going to write them both underneath the cube root as 8 squared x to the 4th. I can't take the cube root of 8 squared as is, because 3 doesn't go under 2. I could do 3, the cube root of x to the 4th. But I could also change this to be 64. And then we have a perfect cube of 64. What is that number? Yes. Yes. What is the cube root of 64? 4. And 3 goes into 4 once, with 1 left over. So that would be 4x times the cube root of x. Any questions, confusions so far? We're going to do some of the negative exponents. Starting with 25, so now we have to remember, what does a negative exponent do? It takes, you make it the reciprocal, you flip it, and make the exponent positive, so that would be the same thing as 1 over 100 to the 1/2. Then I could rewrite 100 to the 1/2 in radical form. What would that be? It'd be 1 over the square root of 100. And we know the square root of 100 is so your final answer would be 1 over 10. one more of the negative exponents, 26, 27, or 28. You guys choose which of those do we want to see you go over and have questions about. If none, we're going to move on. So look at 29. Now the remaining problems are in radical form instead of exponential. So we'll have to rewrite these in exponential form, then use our exponent rules, then convert it back to radical form, then simplify if needed. So this adds an extra step. How would I write this first radical in exponential form? B to the power of 1/3. What about the next one? Now we go back to using our exponent rules, same base, so we're adding the exponents. You have to change them both if we don't have common denominators. So I'm going to multiply one set by 2 and one set by 3. So that our new exponent would be b to the 5/6. And then we could write that in radical format. What would that look like? Sandra, how would we write this in radical format? For this one? Let's say look at some of our previous ones.
I'm not sure. Sorry.
So let's start with the denominator. That's going to be the number on the outside.
Alright, so 6 square root is 5.
So it would be the 6th root of b to the power cup. Do you have any questions on that? Are there any others, 30 through 34, we want to see you go over, have questions about?
32.
Okay. Okay, so same thing, let's rewrite these into exponential form. How would I write the square root of 7 to the 3rd power? And how would I write this in exponential format? What type of root is it? So it's not a cube root, because there's not a 3 out there. It's not a 4th root. It's just a regular square root. So your fraction is going to have something to do with the 2 in it. That's going to be in your denominator. The exponent is going to be in your numerator. using our index of 2 and our exponent of 3. What would the denominator be? Based on this. What would our denominator be? This number outside of here. So that would be in our denominator. What would the number in our numerator be? 3. How would I write the square root of 7 in radical form? Again, we have like bases for dividing, so we're going to subtract the exponents. What would that new exponent be? 1. So this would be 7 to the 2 over 2, which is simplified to just be 1, which is just 7. I am going to put this one into the calculator so you can see that it works. Are there any others we want to see to go over in 30 through 34? This is a Delta Math, but this one for you guys is not due until next week. You could try it while it's fresh in your minds. You guys do have 3 Delta Maths due today. Your curve of best fit, your simplifying radicals. Sorry, this year. Curve of best fit and simplifying radicals. You could also be working on past Delta Math. Be working on J-Labs, be working on the test nav that's due on Tuesday. There are also practice quizzes for Unit 9 and 10 still out. Be working